Facial recognition at scale, the machine that knows your face. Imagine walking through an airport, a train station, a mall, or a city square, and somewhere, silently, a machine glances at your face and asks one question. Have I seen you before? Not in poetry, not in science fiction, not in some dystopian trailer narrated by a man with a suspiciously dramatic British accent. In real life. Because facial recognition at scale is no longer a laboratory magic trick. It is real, benchmarked, and deployed. The National Institute of Standards and Technology, NIST, has tested face recognition algorithms on massive datasets, including evaluations involving more than 18 million images of more than 8 million people, and for one-to-many identification, galleries containing at least 10 million identities. And yet this story is not just about engineering brilliance. It is also about error, bias, misidentification, surveillance, power. Because the same machine that helps verify your passport can also falsely accuse a stranger in a store. The same code that finds a missing person can also become a tool for mass tracking if used carelessly or abusively. NIST has found demographic performance differences in the majority of algorithms it studied, while U.S. regulators and European lawmakers have warned or acted against harmful uses. So tonight, we go down the rabbit hole. Not the confusing kind where you emerge 3 hours later believing your toaster is in a conspiracy. No, a guided descent. We will follow the trail, from how the machine sees, to how it searches millions, to why benchmark scores matter, to where the controversy begins, to the haunting question at the center of it all. When a machine can recognize faces at population scale, who gets recognized and who gets misrecognized? There was a time when recognizing a face was a deeply human thing. A mother across a crowded market, an old friend at the edge of a church hall, a king spotting an ally in battle, a debtor spotting a creditor and suddenly discovering a strong interest in the architecture of the nearest alleyway. Human beings evolved to read faces because faces matter. A face is identity compressed into geometry. Distance between the eyes, shape of the jaw, curve of the cheekbones, texture, symmetry, shadow. Facial recognition technology takes that ancient human instinct and industrializes it. It turns face into math, math into templates, templates into search, and search into decision. At its simplest, facial recognition compares facial features from one image to another for either verification or identification. NIST distinguishes these clearly. Verification is one-to-one matching. Are you who you claim to be? While identification is one-to-many search. Who are you among all these faces? That distinction matters, because unlocking your phone is one thing. Searching your face against a database of millions is another thing entirely. That is where the phrase, "at scale," stops sounding technical and starts sounding political. How the machine sees. Let's begin with the illusion. The machine does not see a face the way you do. It does not see kindness in the eyes. It does not see, "This guy looks like he definitely starts every sentence with 'actually.' It does not see regret, history, charisma, or the fact that someone's barber committed a nonviolent crime. It sees data. A facial recognition pipeline usually starts by detecting that a face is present, then locating landmarks or extracting features, then converting that face into a numerical representation that can be compared against others. NIST's description separates face detection, face analysis, and face recognition. Detection asks whether a face is present, analysis infers attributes, and recognition compares facial features for verification or identification. That template is not usually a photograph stored like a tiny mugshot in a drawer. It is more like a compact mathematical signature. Then comes the comparison. If the system is doing one-to-one verification, it checks whether the face in front of the camera matches the enrolled face tied to a claimed identity. That's the passport gate, the smartphone unlock, the secure access checkpoint. If the system is doing one-to-N identification, it searches one face against many, potentially millions, to find candidate matches. NIST's RFT 1-to-N program explicitly evaluates algorithms searching galleries with at least 10 million identities. That's the leap. Verification is a bouncer checking your ID. Identification is a detective flipping through an entire planet-sized yearbook at machine speed. The age of the benchmark. Now, here is where the story becomes modern. Once upon a time, tech companies could wave their hands and say, "Our system is highly accurate," which in corporate dialect often translates to, "We brought a PowerPoint, a confidence level, and vibes." But facial recognition got dragged into the cold light of benchmarking. NIST's Face Recognition Vendor Test, RFVT, became one of the defining independent evaluation programs in the field. It continuously evaluates algorithms submitted by developers from industry and academia using very large image sets across multiple tracks relevant to face recognition. This matters because benchmarking does something glorious and rude. It replaces marketing language with measurable performance. Not best in class, not AI-powered next-generation identity solution, not revolutionary paradigm shift. Numbers. False match rate, false non-match rate, identification accuracy, throughput, demographic differentials, real tests, real datasets, real consequences. NIST has reported that FRVT demographic testing covered nearly 200 algorithms from nearly 100 developers using more than 18 million images of more than 8 million people, and for one-to-many identification, galleries containing at least 10 million identities. And NIST has also emphasized an important boundary. It evaluates the underlying algorithms submitted to it, not the final commercial products as deployed in the wild. That caveat is huge, because a strong engine doesn't guarantee a safe car. A benchmarked algorithm can still be embedded in a reckless product, used with bad cameras, sloppy watch lists, poor thresholds, untrained staff, or zero safeguards. In other words, a sharp sword in a fool's hand is still dangerous. Why scale changes everything. Here's the part many people miss. At small scale, errors can look tiny. At large scale, tiny errors become crowds. Suppose a system is 99-point-something% accurate. Sounds wonderful. Investors exhale, product managers smile, someone orders expensive coffee. But if you're comparing one face against millions of entries, even very low false match probabilities can generate serious operational problems if thresholds, watch lists, or downstream procedures are poor. That's exactly why NIST tracks false match and false non-match behavior so closely, especially in large-scale identification settings. Scale is multiplication. A one-off mistake is embarrassing. A repeated mistake becomes policy. A policy mistake becomes infrastructure. And infrastructure is hard to argue with because it feels neutral. The camera does not shout. The server does not sneer. The dashboard does not pound the table. It just returns a candidate match and lets humans pretend the machine is objective. But objective-looking systems can distribute error unevenly, and that's where the controversy stops being abstract. The ghost in the dataset. NIST's 2019 demographic study landed like a drumbeat in this conversation. The agency said that the majority of face recognition algorithms it studied showed demographic differentials. In plain English, performance varied across demographic groups. NIST was careful. It didn't say every algorithm behaves the same. In fact, it explicitly warned against making blanket statements across all algorithms. But it did find empirical evidence that differential performance was common in the evaluated set. This is one of the most important technical truths in the whole story. There is no such thing as facial recognition in the singular. There are algorithms, many of them, different designs, different training data, different thresholds, different deployment conditions. Some are better, some are worse,
Some fail differently. NIST later summarized that for more recent algorithms, the range of performance across algorithms is larger than the range across demographics in some of its charts, and that more accurate algorithms can also show lower differentials. That's a crucial nuance. It means the debate is not perfect technology versus worthless technology. It's much messier. Some systems are substantially better than others, but even good systems require careful threshold setting, domain-appropriate data, human oversight, and guardrails. And data is where the ghost lives. If your training data is uneven, if your benchmark data hides blind spots, if your operational environment differs from the lab, then the machine may become very confident in ways that are very inconvenient for the people it gets wrong. Computers are famous for doing exactly what they're told and absolutely
none of what you hoped. Deployment, from passport gates to public streets. Now let's talk deployment. Facial recognition is not a speculative future thing. It is already used in real applications, including identity verification contexts like passport processing and access control. And NIST's programs are built around operationally relevant use cases such as verification and identification. That is the legitimate side of the story. At a border checkpoint, the question might be, does this traveler match the passport photo? At a phone screen, is this the enrolled user? At a secure facility, does this employee match the identity on file? Those are bounded questions. But then deployment expands. Retail, law enforcement, public surveillance, watch lists, live camera feeds, searches against huge databases. And once you cross into remote identification in public space, the societal stakes change fast. The FTC warned in 2023 that biometric technologies, including facial recognition, can expose people to serious risks. Large biometric databases can become attractive targets for malicious actors. Some systems may show higher error rates for certain populations, and location-linked identification can reveal sensitive information about whether people visited healthcare facilities, religious services, or political or union meetings. That is no longer just an engineering conversation. That is civil liberties territory. Because if face becomes a universal key, then whoever controls the lock system controls more than convenience. They control legibility, visibility, trackability. They control who can move uncounted. When the machine is wrong. Every powerful technology eventually meets its moral exam in the courtroom, the regulator's office, or the headline. For facial recognition, one stark example came from the U.S. Federal Trade Commission against Rite Aid. In December 2023, the FTC said Rite Aid used AI-based facial recognition in hundreds of stores from 2012 to 2020 without reasonable safeguards, leading to false flags and humiliating consequences for customers. The FTC said consumers were wrongly accused, followed, searched, ordered to leave, or confronted by police, and that the harms disproportionately affected people of color. That case matters because it destroys the fantasy that error is just a spreadsheet inconvenience. A false positive is not merely model drift. Sometimes it is a mother embarrassed in front of her children. Sometimes it is a teenager treated like a criminal. Sometimes it is a store employee trusting a dashboard more than a human face standing right there saying, "You have the wrong person." The FTC also said Rite Aid's system was more likely to generate false positives in stores located in plurality Black and Asian communities than in plurality white communities. That is the dark arithmetic of scaled error. When a biased or poorly governed system spreads, the damage does not fall like gentle rain. It falls in patterns, and patterns become injustice with a technical manual attached. The law arrives late, wearing glasses.
Technology often shows up like a rock band, and regulation arrives like an accountant with folders. But eventually, law catches up. In the European Union, the AI Act created a risk-based legal framework for AI systems, including biometric systems. The law bans certain AI practices and imposes requirements on high-risk systems. For facial recognition specifically, the AI Act's FAQ explains that most biometric AI systems are not prohibited, but some uses are. It highlights restrictions on practices such as real-time remote biometric identification in publicly accessible spaces for law enforcement, subject to narrow exceptions, and treats certain biometric applications as high risk, requiring obligations around data governance, documentation, logging, human oversight, robustness, accuracy, and security. That is a major historical moment, because societies are beginning to say, we are not only judging whether this technology works, we are judging where it may be used, by whom, under what conditions, with what oversight, and with what rights reserved to the people being scanned. That is the real maturity test for civilization, not whether we can build the machine, whether we can restrain it. Any society can invent a sharper spear. The harder achievement is deciding when not to throw it. The deep question. Now we arrive at the philosophical center. Why does facial recognition unsettle people so deeply? Because your face is not like a password. You can change a password. You can reset a PIN. You can burn an ID card. But your face goes everywhere you go. It is exposed by default, to cameras, to strangers, to platforms, to governments, to private databases, to badly secured systems, to systems you never consented to systems you may not even know exist. The FTC's warning captured this unease. Biometric identification tied to particular locations can reveal deeply sensitive information, while large biometric databases create privacy and security risks that are qualitatively serious. So the controversy is not just, is the algorithm accurate enough? It's also, should this use case exist at all? What due process exists after a false match? Who audits the watch list? Who trained the operators? Who bears the harm when the system is wrong? Can the public opt out? Can a face become a permanent tracking beacon in daily life? And perhaps the oldest question of all, what happens when recognition becomes power? What the honest conclusion looks like. Here's the honest version, stripped of hype and stripped of panic. Facial recognition at scale is real. It has been independently benchmarked. It is deployed in meaningful settings, and some systems are far more capable than the public debate sometimes assumes. NIST's evaluations demonstrate major performance gains over time and the feasibility of searching very large galleries. But the controversy is also real. NIST has documented demographic differentials in the majority of algorithms it studied. The FTC has warned about bias, privacy harms, and misuse, and has taken enforcement action where poor safeguards led to false accusations and disproportionate harm. So the correct takeaway is neither relax, the machine is flawless, nor burn every camera, civilization is over. The correct takeaway is harder. It's this: capability is not legitimacy. A system can work and still be misused. A system can be benchmarked and still be badly deployed. A system can be useful in narrow contexts and dangerous in broad ones. A system can reduce one kind of risk while creating another. That's adulthood in the age of AI, not worshiping the machine, not screaming at the machine, but forcing it to earn its place under rules worthy of human beings. So the next time you hear someone say facial recognition is just software, remember what that really means. It means mathematics touching identity, databases touching movement, probability touching reputation, and power touching the most public part of your body, your face.
the thing your mother knew before you could speak, the thing your friends scanned for truth, the thing painters chased, poets praised, and bad passport photographers have betrayed for generations. Now machines chase it too. And the question is no longer whether they can. The question is whether we are wise enough to decide where they should. If this video made you rethink what a camera really is in the age of AI, hit like, subscribe, and share this with somebody who still thinks facial recognition is just smart photo sorting. And if you want the next episode, I'll take you even deeper. How watch lists, thresholds, and false positives turn AI errors into real-world accusations. Because that rabbit hole, it gets darker and more important.